is our second flipped lecture, and this is on arithmetic sequences and series. And this first little video, sequences, sequences and series. This first little video is a sort of a recall from Algebra 2. So you should already know this information. There's two formulas that we're going to look at. One is a sequence formula. A sub n is equal to a sub 1 plus n minus 1 times a common difference. And the series formula, which I'm going to call little Gauss's formula, and there's a little story with that. The series formula, S sub n, is equal to n over 2 times a sub 1 plus a sub n. So certainly you have to remember these two formulas for sequences and series, but let's look at an example and sort of see how they work. So let's consider, first we'll do the sequence. These are also called progressions or progression. And the particular progression I want to look at is going to be the same as the one that's on the topics page, the handout. Consider the sequence 5, 8, 11, 14, 17, 20, 23, and so forth. Okay, so this can obviously go on forever. We're going to be considering finite sequences in this course. The infinite sequences come in calculus. Okay, so here's an infinite or a finite sequence or progression, and it's pretty clear what's happening here. To get from one term to the next, we simply add 3. So if we added 3, this next term would be 26, and then we added 3 more, we get 29, and so forth. Okay, so here's the formula again. A sub n is a sub 1 plus n minus 1 times d. And we should probably clarify, what do we mean by these? The d is the most important thing. This is called the common difference. Common difference. And that is the difference between consecutive terms. F-E-R-E-N-C, difference. Okay, so the common difference, if you subtract 20 from 23, you get 3. And you subtract 17 from 20, you get 3, and so forth. Okay, so every time you subtract, you always get 3. 8 from 11 is 3, 5 from 8 is 3. So the difference is the same. It's a common difference. So yeah, we're subtracting 3 if we took the 20th term and we subtracted the 19th term. In this case, we'd always get 3. That's our common difference. Of course, to get from the 19th term to the 20th term, you would add 3, and that's what we noted up here. Okay. Now, how about these other things? A sub n represents the first term. The first term of the sequence, or the first term of the progression. And in this example, it's simply the number 5. Okay, so here's the first term. A sub n is a little bit more general. Okay, so a sub n is the nth term, where n is any natural number. We should probably, review natural numbers. The natural numbers start with 1, the integers, right? Starting with 1 positive integers, 1, 2, 3. Okay, so a sub n could be a sub 1. That's a nth term, or a sub 2, or a sub 3, and so forth. So if the subscript is 1, if the subscript is 1, this represents the first term. And we already know what that is for our particular sequence. That was 5. If the subscript was 2, that represents the second term. Okay, and in our particular sequence, we note that's 8. There we go. The second term is 8. 8. Okay, a sub 3, just to beat a dead horse to death here. The third term, and that's obviously 11. Now notice you can also do this if I give you a term. Suppose I looked at a particular term in here and I said, well, shoot, 29 is in this list. 29 is in the list. Which term is that? 29. So I don't particularly know what that term is. I know it's in the list, so maybe I might be asked to find what is in. Don't know. Well, one way to do it would obviously be to count. Let's see, here's our first term, second term, third term, fourth, fifth, sixth, seventh, eighth, ninth. So 29 would be the ninth term just by looking at the list that we have. So 29 is the ninth term, so that would be A sub 9. Okay, so we can sort of get the idea of what's, and then obviously in here is the numbers, the ordinal term. That's sort of a fancy word. The ordinal could be the first or the second. Okay, so it's the nth term. This number n is the same as the subscript over here. Okay, so we sort of get the idea. We have a sub n with the subscript. We have the first term, we have n minus 1, and then we have the difference. And let's just go ahead and show how it works for a particular example. Let's take the number 23. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So this is the seventh term. So a sub 7, we already know this is supposed to be 23, right? It's supposed to be the first term, a sub 1, plus 7 minus 1 times the difference, which in this case is 3. Let's see, so a sub 7, the first term was 5. 7 minus 1 is 6 times 3. Okay, so a sub 7, 7 plus 18, which is 25. Okay, 25. Oops. Where did I go wrong? The nth term. 7. 1, 2, 3, 4, 5, 6, 7. It's supposed to be 23. 6 times 3 is 18. 18 plus 5. Write down the correct term there, Joe. And now we're good. 20. Okay, sorry about that misread. Yeah, so this formula now can be used to find any term in the sequence. Here's a typical problem. Again, we'll use this particular progression as sort of our guinea pig. And I might ask, what is the 100th term in this list? Well, no one's expecting you to write out 100 terms. That would be silly. But if you know the formula, then you can easily calculate the 100th term. Let's see, here's the formula again. A sub n is a sub 1 plus n minus 1 times d. I want the 100th term, so my subscript is 100. The first term is 5. N is 100 because I'm asking for the 100th term. I have to subtract 1, multiply by the difference, which is 3. Okay, so just simplifying that, I would get a sub 100. The 100th term in this particular progression is 5 plus 99 times 3. Make sure you use order of operations here. And you can use your calculator. I don't have any problem with that. Okay, so the 100th term is equal to 5 plus 297 or 302. Okay, so the 100th term of this particular sequence is 302. Okay, so let me go ahead and stop this particular segment here. I'm going to do another little video on series. We're going to add things up. But right now we're looking at sequences. Okie dokie.